And probably one very common way out there in the field is when the station is running to both COS and UNICOS systems. Now this is true simply because a lot of sites want to continue keeping batch access to their system because that's the best way to get the throughput on the system. If you have interactive access, you'll probably have TCP available. So this is just one of the many ways of getting files across. But station-to-station transfer is using the station. And again, if your database, your source and all that type of stuff is maintained on the station, like an MVS environment is really where this method fits in the best. You don't have to actually move it from COS to the station. It's already on the station. But in this case, we're assuming that it's on the station and we don't have ghosts, we don't have the internal station or anything like that. So we sit on COS, and the only way to get out of COS is to dispose to the appropriate station. And the training pyramid in this building is station TB to the COS machine. So we're going to dispose our file to the training pyramid, transparent format. It's first of all, binaries and PLs have to be in transparent format. It's been my policy that everything can be in transparent format, and then you can pull it apart on the UNICOS side. And I'll explain why with COS read a little bit later. The main reason, though, is, for example, with this BOPACE application, it has an input data set that's huge, composed of like 8 separate data files. So it's a multi-file text data set. Now, if I leave that blocked by the station and let the station convert it to Unix format, I won't be able to pull it apart very easily. If I leave it in transparent format, then I can pull it apart. So it really depends upon what you're transferring across if you want it transparent. So what I'm just going to say is multi-file text, which may include a job where the job is contained in $in and you want to split $in apart. So by keeping it in transparent format, COS read can pull it apart. That's the thing. Otherwise, you go in with an editor and try to split it apart, and it's really impossible. Let COS read do it for you, because he knows what into file marks look like, the /EOFs and ~es look like. So multi-file text data sets, binaries, these are input binaries, possibly output binaries from a previous front-end application that this thing's going to process, and program libraries, because update expects it to be in update format. The things that you would do in character blocked are just, for example, it's all source in one file. There's no /EOFs or ~es in there. Then why go through this conversion on the mainframe? Do it through the station. And then on UNICOS, assuming you only have a batch interface or a station interface to UNICOS, you would then fetch it in. Name of the file is going to be file. That's what it's going to be called on UNICOS. And these are position sensitive. -M is the mainframe type, TB. -F is the format for the file, TR, and it has to be, these have to be capital letters. And then -T for text field, and this is the path name of where I disposed it off to from COS. So multi-file text, files, binary, and PLs. If you keep them in transparent format, COS read can process them. Or PLs, there's PL copy that will process it. Binaries, the application's going to process it. Now, if you have the internal station and your database is on CRAE disk, then the internal station is what's most useful and most efficient to get your data transferred from one set of disks to the other. And the internal station is a memory-to-memory transfer. So we have buffers up here. These would be the segment buffers for the station. And the station is called GX. That's the default station ID for the GOS internal station. So UNICOS is looked at as a GX station. And then down here, these are the station buffers within the station itself. Now, all this is done with a vector block transfer, using like the copy routine that they have to do job moves and stuff as well. So V0 and V1 are used to move these two buffers, doing a vector block transfer in and out of the V registers, V0 and V1. So that's going to be your quickest, fastest way. You still have the impact on the rest of the system of using those vector registers, but it's faster than going through the network in a lot of cases. And again, the same rules apply. If it's a binary data or program library, transparent mode. And multi-file text data sets, you would also want to do transparent mode, because then you can pull them apart easier. The way we use around here most often, because we have only a station talking to COS and TCP talking to UNICOS, we could use the station as an example, but I generally go interactive when I can. I'm spoiled on interactive capabilities. So this is the way you do it with TCP. Again, we still have the only way to get out of COS is either write a tape or dispose it off to a station. Those are the only two outs on a Cray system. Or I suppose Superlink or something like that could be used as well, taking Superlink into account. Transparent format, again, dispose it off. This is the same dispose statement we saw before. But now when we're on the front end, if we have TCP connecting to UNICOS, we can use FTP or we can use RCP to transfer the file. Now with FTP, in this case, we're going to do FTP SN218 to go to 218. FTP has a binary mode. That's the same thing as a transparent mode for the dispose statement. So you have to type in bin or binary in order to get it to not corrupt the file. If you don't do that, PLs will not be readable by update. Your application won't understand the input data, these sorts of problems. And in this case, I simply send the file to 218, and it's going to go across in binary mode and not be corrupted by the TCP communication link. Now, RCP is what I use more often because I have my .rhost file already set up. It's less keystrokes, and I don't have to specify binary mode. It doesn't touch the file or anything. So in this case, I do a remote copy from the front end. In this case, it'd be training, :file, and I'm typing this in on a UNICOS machine to my local directory named file. Or if I were on the front end, RCP file to the, that shouldn't be front end, but that should be more like UNICOS, like SN218, :file. And you don't have to specify binary mode with that. That's what I have down here, is that sort of example. So to me, it's less keystrokes in a single line rather than going through FTP and the login process and that sort of stuff. Now, I mentioned yesterday, and we'll go through it again now, that when we're on UNICOS, we've got 4 file format types. These are the structures, and the I/O optimization handout I gave you actually shows octal dumps of these structures and can show you details of what they look like. But the first one is what is a standard Unix file. It's a text data set, character data, each record's terminated by a new line, or \n. Any size request is allowed. This type of file has library and system buffering occurring. The handout I gave you actually shows the buffer orientation, that sort of thing. And it's the default format type and different from the default binary type, which is like in COS. So in UNICOS, your default is this text unblocked file. We then have a blocked format, and this is only gotten to with the assign command. I think it's a -s COS, something like that. And on the Cray 2, it's called unblocked rather than COS. So this area is actually a port of the Cal libraries from COS with 4.0. And any size request is allowed again. You have library and system buffering still. The difference about this data set that it's already sectorized, already blocked for the particular disk drives that we use. And we have block control words and record control words just like we have in COS. And we now have file marks. It's a multi-file data set now. And that was new with 4.0 and on the Cray 2 with 5.0. This is the default for our unformatted and buffered I.O. just like in COS. So buff in, buff out, all those work on the same defaults. The next one is really a raw I.O., unblocked data sets. This is done with the assign command. Again, the assign command is what sets up this environment for these different file formats. And this is pure data being read directly from the user space off to the devices. There's no system or library buffering occurring with this. No control words added. And it has to be a 512-word multiple request, because we need to know that it's going to come out properly for sectoring. So again, these are gotten with the, all of these are gotten with the assign command. Without the assign command, it defaults to just a text data set. UNICOS binary, pure data, buffered by library and cached by the system. This one requires no control words, library and system level buffering. You don't require it to be in 512-word multiples, and is treated as a normal UNICOS binary. So what we've added with the I.O. libraries and the assign command is the capability of coming up with 2 different additional file formats. In particular for I.O. performance, and in particular to orient it towards the type of disk drives that we use. A little bit different than a floppy disk that standard Unix was designed for. Now the station can do some of the blocked to text conversion. But if you're transferring across with tape, we do have the capability of writing a PDS dump tape in COS, mounting the tape on a UNICOS system, and if it's an expander tape, we read it in with EXTD. And if it's an online tape, we need the RSV and TPMNT commands to read it in. Once we read this file in, we then can use a tool called COS read, and this is a migration tool. I don't know if it's actually going to get worked into a future UNICOS release, but right now it's its own release tape, the migration tools tape that the JCL converter comes on to. And it's also in my tool 3.0 directory that I specified yesterday. Now with COS read, he's going to look for EOF marks, tilde-E marks, and he's going to deal with record control words and block control words and convert the thing to the appropriate format in UNICOS. And the way I use them is I first of all let him default to thinking everything is text, because you're going to have text files that you're going to be converting. So I typically just run them by default, and I'll show you the job example on the next page, and generate everything into text files. I then look and see what he pulled out of that file, what he pulled out of that PDS format data set, and say, oh, this one's binary, this one I've got to deal with, etc. So I'll then go back and pull out any binary files or PLs by recognizing their name and pull them out uniquely. Now, this is where the user really has to know what his file names mean. Hopefully he uses a convention like PL at the end of the PL names, and this some sort of bin or something like that to identify what binary files he has. If it's text stuff, then you can let COS read split it apart by default. But it's the binary stuff like IBM integer numbers, things like that, that you're going to have to pull out uniquely. And if it's a program library, you then run it through PL copy, and PL copy will split it or create the appropriate format for update, new update, and there's going to be a variety of options with PL copy in the future to convert it between different format, SCM and that sort of thing as well. And it's going to tie into this new SM source maintenance utility that's coming out with 5.0. So there will be a lot of changes with PL copy in the 5.0 release, and I haven't seen those changes yet. Now if I happen to transfer, I have a note here, if I happen to transfer this thing in character block format, there is a command on UNICOS with 4.0 called USCP block. and I can reblock anything. I would prefer to get it clean from UNICOS because I don't know what sort of corruption I may have. But I can try reblocking it. If it's a character data set that I know is still intact, I can reblock that thing and then run it through COS read and split it apart. And it has a -B saying block it, -F saying it's going to be character block format, and then the in data and the output data that you want. The input file name and the output file name. So USCP block is a 4.0 support. I have another note here that I wanted to point out, that when you're reading in online tapes, if they're a labeled tape, on the TPMNT command, you have to have a -A with the proper label name, in this case a ANSI label, and the -F has to match whatever the name of that tape was written as. Otherwise it won't read it correctly, just like in COS. So hopefully you know what the name of the file or the name of the tape as it was written is, and a job that wrote it is very useful if you come into Mendota to load these tapes on. I have had students where we got stuck with that. In this last class, instead of using $PDS as a default on access, they used PDS. So they did a PDS dump to PDS. And when we loaded it here, I assumed it was $PDS until we looked at the job output. But we were over there and the job output was in this building, so we didn't bring it with us. I also had the case where a student bringing tapes in didn't look at their job output and got here and realized that they didn't write anything. The PDS dump said no data sets dumped. A novice user of dumping to tape or something like that. So be sure that if you come to Mendota, you've got a tape that's correctly dumped. Sometimes they have problems with archiving. Archiving will kick in and you won't be able to dump everything because they'll start archiving things while you're trying to dump it. What they've done in those cases is assign to a scratch device or buffer memory or SSD, wherever there's enough space for the files. PDS dump it to that and then write that to tape. So you can get into complications of making sure that you get everything off the system correctly. Be careful also that PDS dump does not tell you if it skips files because they're archived and they're not online. So PDS dump only dumps things that are online and also cannot be local to the job. In fact, that's what happened with this one person. They didn't dump correctly because they accessed them to make them online and then didn't release them, and then PDS dumped them and it said local. Can't dump them. So you've got to be real cautious that you're bringing a good tape with you and know what the job output looks like and that it looks correct. In this case, the student happened to have an MS-DOS backup of their stuff, and we loaded it onto an IBM here and used Kermit to put it on the pyramid and then onto training. So sometimes bringing two backups from the same job, the tapes may be good, but the job may not be good. And be cautious of that sort of thing. I've only had one student come to the application conversion class that couldn't read their tapes, and it was a CDC format tape that we were never able to pull apart or cleanly. I think he had to go in with an editor and change every line because there were some garbage characters at the end of the lines or something from the record numbers, something like that. So COS read is what we're going to look at next. There are some options mentioned. There's also a migration note describing it in your anthology. And I would prefer that COS read be done interactive. I used it interactively, and that's what this output looks like. I think with UNICOS 5.0, the best thing to do is to give them interactive access until they're past the implementation stage, because they're going to be able to implement it faster in an interactive mode than a batch mode. And you simply control the number of interactive accesses to the machine and then shut it off, because UDB Gen has the ability to turn interactive access on or off, a flag that's in the user database. So their CDBX and all these tools are much better to use interactively. Once it's implemented, put it into an NQS production environment. But give the guy a break in getting the thing running at least. Makes it a little easier to troubleshoot. So in this case, I read a file. I don't show the job that read the file in, but I read it in with an extd command into a data set or a file called PDS file. And I do a COS read Hyphen L says long listing. Hyphen L is what generated all of this. And then a PDS file. So it's default. Now the reason I did a hyphen L is so that I know what he finds. I don't want to run COS read PDS file and then find all these files and not know what the original name was. It cannot keep the original name by default because there are too many attributes and stuff. What if you have edition 1, edition 2, edition 3? You just get into a path name that's too long. So it's going to rename them PDS file .f1, .f2 for file 1, file 2, or we're going to, on the facing page it shows it, P1, F1, P2, F1, P3, F1, that sort of thing. Now when you do this, a lot of times you don't know everything that's in that PDS format. So my recommendation is rather than letting it come out to the screen, you redirect it, that's a greater than sign, to some output. That way you've got it hard copy and it doesn't pop past the screen and you're stuck without what the heck did it do to this file. Because this is an important listing. It tells me what it found and what it renamed it as. And hopefully the person that's doing this has some understanding of what the names mean. Job IDs. A $miglib, that would be a binary library that's no good. We don't want it. It's something that we're going to regenerate or something like that. A PL. Hopefully they use PL naming conventions so that we can say that that one now has to be pulled out differently. So by saving this output, you then know what you've pulled out of this PDS format file. By the way, if it's not in PDS format, if it's just a binary, it can be converted as well. So there are two modes for this. It'll pull out split apart blocked files as well as text files like this. So the facing page then shows what I have after I ran that COS read. And again, you can see why it's nice to save that output from COS read, because I look at this and they mean nothing to me. They don't make any sense to me. I'm going to have to go in and rename them. Now if I pull them out explicitly, then they'll keep the original name, and I'll show that down here. So looking in here, I can see for example, permanent data set 9 was split apart into 3 files. Permanent data set 26 was split apart into 9 files. And those 2 data sets, one happened to be a PL and the other one happened to be a procedure library. So each procedure got split into a separate file there. The procedure might not be too bad splitting that apart, because this is /EOS between each procedure, and there's no proc in proc there, and I could just work with them as they are if I wanted to. But the JCL converter won't understand them because there's no proc or in proc there anymore. So they may still be usable though. And then the PL is definitely no longer usable because it's been corrupted now. The PL's been split into 3 files. So in this case then, I went back and explicitly pulled out the things I knew got corrupted. There weren't any binary data sets in this example, but there was a PL. So I then do a COS read. -C says leave it in COS format. Leave COS file unchanged. So that's going to leave it blocked, etc. The -P is then going to be the permanent data set name, PDN, that I'm looking for. -I is the ID that I'm looking for, and then the file that I'm pulling it out of. So now I've explicitly specified which PDN and which ID I want, and it will now keep the file name. So when I pull it out, it says it found it and converted it to MIGRPL, and it did keep it uppercase. I then used PL copy on that thing, did a -I. My first time I did it wrong. I need the options in front of it. So PL copy -I is MIGPR, -O, new PL. I then ran update on new PL and got the ID options. And there was one deck in here named scan, which is the same example that the $dummy-lib was run on. So you can see how the person using this really has to understand what's in the file. Now I have found that it has problems with PDS files buried in the PDS file, where it gets lost in the block count numbers or PDS count numbers, things like that. This is supposedly going to be SPR product. In other words, if there is something wrong in the field, you can SPR any of the migration tools. That's what we're told right now. I, however, am not sure what person's going to support them at this point. They have been on the back burner for so long, people with higher priorities, that there are several known problems that haven't been fixed on the distributed release. Yes, there's a migration node in the anthology, and there's a man page that comes with it when you get the release. No, it won't be in the 2011 manual. PL copy is, but not COS read. No, simply because they've been released separately. But yeah, it's not in the 2011 manual for sure. PL copy is. I don't have my anthology here, but the table of contents will give it. File format conversion, page 285 in your anthology. I've been trying to work in some I/O differences into this chapter. Seemed a good place to work it into. But this is some of the Cray2 again is different, but with the XMP, the similarities between the two systems. Blocked files are the default for unformatted reads, writes, buff-ins, buff-outs. And raw files are for word addressable files, the unblocked binary structure. SSD files and buffer memory resident files are available. You can, we've mentioned how they're done. SSD and buffer memory are treated the same. They could be file system, logical device cache, or SDS configurations. And then unblocked files are the default for direct transfers. There are some differences. Character files are not compatible between the two systems. They have different meanings. And COS read will convert a COS text file to a UNICOS format. We have no tool to go the other way. It's been talked about, some people wanting to go from UNICOS back to COS and convert UNICOS files back to COS files. Right now, the station is the only way to do that. Nothing like COS, nothing opposite of COS read as a command. Though I suppose USCP block can reblock things too. There's no circular I/O in the system. The default for buff in out is not asynchronous. Now this slide was made up in a 3.0 release, and 5.0 there may be changes, but I don't think so. I think this is pretty accurate. I should have somebody check it for 5.0. There's an additional file type of bin, which is the system, or the UNICOS binary structure, which is system buffered and stuff, and unblocked. And again, this is the assign command that gets that. So we've got an extra file type. That was one of those, that UNICOS file type that we talked about. The default buff in out is not a system hog. I don't know what that means in COS, if it is in COS. I guess because it's synchronous in COS, that may be why it's more of a hog, but I don't know specifically why they said that. Most of the Fortran libraries use system buffering, and the system buffering now can use logical device cache and put those buffers on the SSD. Performance pluses. There's less system overhead in processing I/O calls. We saw that yesterday, at least in the number of exchanges and path length to get I/O initiated. Much shorter thread of code to initiate I/O. We have the hot path to the SSD. I mentioned that yesterday. As soon as we go into the kernel, he can look for a SSD transfer and go straight to the SSD and quite a bit different from COS, where you have to go through a lot of tasks and stuff to synchronize that transfer. We have this bin file type, and the bin file type is the new UNICOS file type that's system buffered. And we have the system buffer cache capability and logical device cache capability, which is an additional buffer from COS. Some of the minuses that were pointed out, more overhead in some of the I/O library routines. I think that that is obsolete now. You can take that off. They were referring to the fact that formatted I/O was using C library routines. Now that we've redone everything in Cal with 4.0, a lot of the overhead is gone. As I mentioned before, the benchmark showed that UNICOS finished the same number of jobs before COS did, with 321 jobs submitted. Allocation size is at the sector level, and system buffer cache can get in the way. Notice it's as a plus and a minus. You have to understand what it's doing and understand your I/O. Now, I'm not a Fortran I/O programmer. You get into these specifics rather heavily in the Fortran classes, and I've handed out a section from the Fortran workbook discussing some of the optimization practices that you can follow. We also have a chart just showing the default data set types. Sequential formatted is default to text. Sequential unformatted defaults to block. Direct access format obviously is text again, and unformatted is binary. And then list directed is text. And sequential unformatted does have a binary option capability. Now there's one other thing I might point out in this area, the assign command. There's the option of user striping, and there's also a memory resident option. Memory residency is gotten by the file system. This UNICOS supports /mem, if you want to call it that, meaning that part of the file system is memory resident. And you can configure how much memory you're going to give to the file system. So on the assign command, you can specify you want it memory resident. With UNICOS, you simply put it in the memory file system. User striping. User striping is done differently between the X and the 2. And this includes pre-allocation of the striped area that that file is going to use. In COS, it's called a setf command. Or I'm sorry, in the XMP UNICOS, it's called a setf command. In COS, it was the assign UPD equals type stuff. So there's the setf command that says set up this file allocation for you. And on the Cray2, it's done with the assign command in something called cbits. And you set up this bit mask to determine how you're going to allocate it. So it's a different implementation between the two. So everything I've looked at the assign command, except for the foreign data set stuff, can be translated to some UNICOS capability. And the foreign data set stuff is all in 5.0 with the ASG command. But I haven't seen any documentation on it yet. Random data sets I might point out too. With COS, you had to do an RDM on the assign command. In UNICOS, you don't have to do anything with it. It handles it by itself. Let's see. Set pause and get pause are not supported on block files. I've seen that once, and we were able to just code around it. The last page I have in this section is dealing with the procstat output. Now this is probably 6 months old as far as this report goes, and things have possibly changed. There's a procstat command, and you generate some sort of report. And then there's a proc report that looks at the trace that's left by procstat, that analyzes that report and generates it's formatted in both cases, but this proc report generates summaries of it. And I haven't played with proc report at all. Now this is new with 5.0, and this replaces the option stat equals on capability in COS. So you can look at your I/O statistics and see what I/O is going on. So this is basically a trace that's left open. The name of the saying that we're going to execute, the name of the program was a.out, time, and I believe that's process number in that column. We then have a memory setup that's occurring here. Our field length is 65601 words. Requested was 0. That's just to start the job. We open a data set. This is Fortran Unit 10. It's open for read and write. We see a memory allocation change occurring here where we increased up 2,050 words. We open file descriptors 1 and 2. Now these are going to be changed from no name to standard in and standard out. There will be some, mentions that down here, there will be some cosmetic changes occurring in this, and we can try it on the system with BOPACE and see what it looks like these days and run proc report on it. But they're open by default because those are standard in, standard out, open and pre-connected by default by the libraries. Then the job ran and terminated. Here we have our closes of our files, the number of calls that were made, the requested bytes, the number that were transferred, and then the time that it took. So you get some statistics there on each Fortran unit. And then exit a.out. So that's proc stat, and then proc report I don't have a sample of, but that then takes a look at this stuff and gives you totals and summaries and stuff like that. So if you're interested in that sort of thing, it'd probably be worthwhile to try BOPACE 3D on it. And it's documented in various places. In 5.0, I'll have to get you documentation, or there will be man pages on the system that you can use to take a look at it closer. It replaces something that used to be called I/O stat, which was a non-supported tool that kept counters in the C library, opens and closes. And I/O stat is gone. This was based upon that I/O stat, which was never officially released. Any questions in that area? Again, there's that handout you can look through, and if you have questions as you're reading the materials, go ahead and take a look. Is anybody interested in the proc stat man pages and proc report man pages? I'll try to get a copy to everybody. Our next section is real short. Everybody can try logging into the training pyramid. And if you log into the training pyramid, you'll see a front-end version of this thing. It's called the menu system. See, training here went through the same process that everyone else out there went through. We were an MVS shop before we were a Unix shop. And it was several years ago that when we figured out that Cray was going in a Unix direction, we decided to switch our front ends. We were using the IBM that's in the data center and had to fight for resources on that machine. And Pyramid was coming along with a great deal on multiple pyramids to all our different departments. So in come the Pyramid, and we made the decision that it's pretty good to have a Unix machine in our COS shop, because every time users come in to learn COS, they're also going to have to learn Unix. And MVS programmers came in and said, I don't want to learn Unix, and this is too hard for me, and etc. So one of our trainers here in the training building put together this menu system with the idea of modeling it the way SPF menu system works, the way they pop between panels in the MVS environment. And that's what it's all based upon. If you log into training, you should be able to type in menu and get not the version that we're talking about here, but a front-end version of this menu system. And it's a way of probing you and letting you hack around the system without getting operand order switched, things like that. It prompts you for the data. It lets you know what you can do and stuff. Now, the menu system was rewritten and released with the Migration Tools tape and is going to become a standard product. And right now, they're looking at rewriting it from shell scripts into the C language for performance issues. But it was originally written with Bourne shell scripts. And we thought we'd give it to sites and let them use it as a model that they would then start with to build up their own interface out on site. So, you know, it gives you something to start with, shows you how to do it, and then you can start adding your own debug panels and things of that nature. Its intent is for those visiting scientists that don't want to have to learn a Unix system but need to get something done rather quickly. So it increases the learning curve. It speeds up the learning curve of getting a user up on the system. At the same time, it echoes the Unix command line it's issuing to the screen so that the user sees what is actually going to the shell. You had a question?
Yeah, I can see where this would be a help, but how did the MBS people take to VI? VI was only actually...
Yeah, they don't take to VI so well. The problem with VI is it fools you into thinking it's a full screen editor when in fact it has an edit mode and a command mode. And you teach them the escape key a lot. And that generally, once they know that they're escaped, then they remembered it. But yeah, I myself have gotten screwed up in VI. And if your terminal isn't set up right, sometimes the backspaces aren't working right and various other things don't work right. And you have to get used to it. In the future, though, I think we're going to see more Emacs than VI because this new program support environment, PSC environment, is coming up. That PSC environment is on 218, by the way, anybody that wants to take a look at it. And it has a walkthrough tutorial and a complaint panel, too, so that you can send complaints to the developer. So you type in menu, and this basically is a way of prompting you and reminding you what the name of that command is and to get you some help. So menu and also the help command can, you know, get you around the system a little bit easier. So this main UNICOS command menu allows you to change directories, and the directory you're in is up in the far right. A CP will copy. Now originally I wanted to use the COS names over here, at least COS names in there, like copy D and stuff like that, but they chose to make it as Unix-like as possible. The equivalent menu is what we'll call up a COS UNICOS equivalence menu. For that, I'd rather use the JCL converter and the COS help command. ls lists the files. We can make a directory, rename a file, which is the move command, print a file. Now that panel is disconnected. It works here in Mendota Heights, but it's so site-specific. We simply left the hook in there for the site, and then the site has to go to that shell script, and instead of saying, see your site administrator, they set up the print sequence that is appropriate for that site. Remove a file, VI. They can enter a UNICOS command from within the menu system, help, man pages, and quit the menu system. Generally 1 or 2 days and the user is ready to use standard Unix, provided he has some knowledge of what he's doing. But it pops the commands back to the screen for you. And the source for it is in that tool 3.0 directory that I pointed you to. I'm not going to, let's see. The help panel just shows the equivalence for these commands, or shows the meaning of those commands. And there's also an equivalence thing. There isn't a whole lot to talk about with the menu system. You just go in and try it. But your last page, 8.7, shows the commands that are talked about. And we're still teaching ln rather than copy because of the way we used to run in the same file system, that sort of thing. And your site could then go in and modify this to add things the way you want it.
Now, people seem to like it pretty well.
Some people do. I don't know. What have you thought? Here in
UNICOS, I don't even tell them there is such a thing.
Not anymore.
Because I want them to learn the commands. But when I was teaching COS and we were using Pyramid, then they liked it.
It reminds them. That's what it's helpful for. But if they know COS, if these people know COS, then this isn't the tool to give them. The tool to give them would be the JCL converter. And they can do a COS help space audit, and it reminds them this is the LS that you want, that sort of thing, and option mapping and stuff like that. This was designed for the non-programmer types. Some sites, when they realized that training had it, realized that that might be useful, and training did it for our own internal problems, and somebody else said, well, let's make it available. and let these sites determine whether they want it. I don't think I'd want 100 people running it at the same time, that sort of thing. But you know, the guy that's stopping in for a quick Fortran fix or something like that. I myself would probably not put it if it were my site. I don't think that it's appropriate, but it really depends upon your users. And if it's an SPF, MVS type shop, they may like it. And that's what it was written for, those MVS people coming in. They were used to panels and seeing what their options were. Why don't we take a break? I'm ahead of myself here, so the next chapter is rather a long one, and I'd rather take it started after lunch. So I'd like to take a break and let you work on some terminal stuff. I can give you things to do, that sort of thing, for the next 45 minutes. Then we'll talk about the JCL converter after lunch. One thing I can suggest you do is on 218, there's a thing called a dot profile. If you don't have a dot profile set up yet, set one up. And this is what you should put in it. Term equals Ampex. Export term. Path equals $path :/trng/daw/bin, and that'll get you the migration tools in your search path. And also put in that if double quotes backdagger TTY equals not a TTY, then CD to $tempter phi. And that should set you up for proper terminal, to use the migration tools, and for NQS jobs, if you're going to fire NQS jobs off. I was hoping that 218 would be up and available so we could show you what we can do with it. The JCL converter was written by somebody in software development as a language translator, built to parse COS command line structures. And it's composed of 4 tools that are mentioned on page 9.3. And 2 of them I mentioned you would rarely use, CJPrint and CJPlib. CJPrint just makes your JCL more readable, and that's a matter of opinion, I think. It can mark loops, and it can make sense of some JCL that, you know, is hard to understand in structures. It's probably a better structure analyzer than anything. But if I had my way, I wouldn't release it or let users know about it or anything like that. It just makes it more of a mess in dealing with the conversion. And CJPlib I've never had to use. We've always had the source to the procedure library, but it's designed to recover the $proc format data sets that procedure libraries are in when you save $proc. And it's basically proc and inprocs are replaced with /EOFs into file markings. And COS read in the previous section split apart procedure library into individual JCL files. So you can go either way on what to do with those $proc format data sets. I myself would probably just let COS read split them apart and use that rather than try to run them through the JCL converter. Print them and take a look at what those procedures are. Unfortunately, you don't have a name for the procedures because they've all been named by the UNICOS file name. Remember, COS read didn't keep the procedure name, they just whatever name happened to be. It doesn't have any procedure name built into COS read, so that makes it difficult to look at it that way. Typically, I've never seen any large procedure library situations. Most applications are 30 or 40 JCL statements at the most. And I'm sure that, I know that there are others out there, especially in weather modeling and stuff like that. But just have to deal with them one at a time. When you're looking at JCL, it's sometimes better to take a look at the whole design structure of what large procedures are doing and re-implement them in shell scripts, tie them together into one script and things like that, reduce the number of files and various other things that can be done. But it's a case-by-case basis. You have to look at it on what that application's doing. So CJPrint and CJPlib aren't going to be used very often. CJProc is a preprocessor to the real converter, CJCL. What it does is it takes $in and converts it to an ampersand data block. You know, in JCL, implied data within a job stream. And then CJCL just converts that implied data stream into a here document because it can understand what that is and maps it to that same kind of stuff. So the JCL converter takes both the implied data structures that are in your JCL as well as the $in stuff and treats them as here documents. And it treats $in as only one here document. It can't split $in apart. It just takes $in and names it ampersand data, comma, $in. And then the converter can understand that. So CJProc is a preprocessor just for $in, anything with the /EOF, anything with procedures, that sort of thing. Yeah?
How do you handle the ampersand data? With a here doc?
Yeah, just create a here document with that name. That's an easy thing to do. If you want to continue maintaining it with here documents, which is an implementation choice you have to make when you're putting it on a totally new conceptual type system with FM Gen and make files and all these sorts of things. And you want to split your JCL into stuff to generate the binaries and maintain the binaries and stuff to the ones that execute the binaries and generate your output and your data processing runs. You know, separate those into two separate things. One goes into a FM Gen or a makefile type structure, and the other stuff to execute goes into shell scripts that then get NQS directives put in front of them to run them through the batch system. But you can debug it as a script, and then when it's ready, run it through NQS. I've had students do that, where they just interactively debug their shell script in the directory and then switch to NQS. So CJProc is going to deal with all those ampersand data blocks and $in and just treat them as here documents. Tell the converter that they're here documents. Also in COS and UNICOS, it will split procedures apart into separate files in a directory, so it doesn't become one big file. The problem is in COS, you get a bunch of these things with proclib IDs, and then you have to figure out how many you were created and then create an access list to get them back off the system. In COS, there's no easy way to find out what you just created and save them off as one big thing. So the way the thing runs is you get 300 procedures becomes 300 files on COS with an ID of proclib, which is rather hard to manage on a real easy, user-friendly basis. In UNICOS, you could do that real easy with a backdagger execution of LS and do things. It's real easy to do. I'll show you an example of that. So the way I always use CJCL, I always put CJProc in front of it because it never hurts. And I've rewritten it with some shell scripts, and that's what I've got. This is not official, this is just recommended. But I've got 4 shell scripts in my bin directory, and a site can pick and choose how they want to use these. And the difference between them is simply the templates that CJCL uses. And CJCL is the converter that references these templates to say, treat this verb with this verb, and these keyword options translate them to this. And we're going to take a look at a template for update and see how it treats that language.
218's up now.
Okay. Has anybody modified their path variable to include my...
Yes.
Have you tried COS help space audit or something? No.
I'm being told I can't find it.
Okay, let me see what I got here. Why don't you stop the tape for a minute? I want to get this working. Okay, so we've got at least COS help working right now, and you can play around with it a little bit, and I'll explain the templates that are with it right now. And this is unsupported stuff. This is just what I've done with the converter. It took me about 2-3 days of cutting out things from the full-blown templates. So, and these are still at really a 3.0 level, though there's some places where it's updated to 4.0, but definitely not 5.0 stuff in there yet. So what I've done is I put the two products together because they really have to go hand in hand. You always want CJ proc there because the user is going to know whether he needs it or not. And I put them together into 4 shell scripts. And these 4 shell scripts are all one line. They're just CJ proc piped into CJCL. The difference between the 4 versions is whether they're designed for an interactive use. The first 2 are interactive, and the second 2 are for take a file and convert it and give me an output file. Now, this JCL converter has a reputation for generating a lot of stuff. You put in 10 lines of code and you get out 100. That's the full-blown version, what I'm calling COS job right now. I was going to call it COS CONV, but somebody else has that as a 5.0 name already, so I can't use it. And it takes a COS job and converts it into a new job. And this could be a full-blown output, everything you ever wanted to know about every little option that you've specified in your stream. NQS is the second one that I came up with, and I said, okay, now this one maps path names. It maps ownership and all of that stuff, and it maps dollar format data sets, you know, defaults and things like that. And I said, I don't want to try to make it look like a COS job when it's in NQS UNICOS format. So I went into the templates, which were pretty easy to understand. There's a document that describes them in your anthology. But I went in and started cutting out lines and characters and things, patterns and things that I didn't want to come out in my output. I controlled the format of my output. Then I said, well, let's go one step further. Let's have it convert the output and pop it back to the screen. So it's a line-by-line interactive online help system so that a COS user who's on the system can say, COS help audit, what do I do? And it pops back the command. Now, I haven't put any sort of text, but a site or pubs or somewhere down the line we could put in text format, descriptive messages too, and have a flag to turn that on and off. There are flag capabilities in the templates to say a comment flag, for example, that would pop that back. So NQS takes a COS job and converts it into an NQS script, throwing away anything that's COS-like and trying to make as sensible a script as possible to run this thing in UNICOS NQS. And it doesn't try to outsmart anything, it just does a one-to-one translation. It doesn't expect to run the output either, it just saves you a lot of keystrokes, converts the lines for you. And it can also put the original line in there as a comment so you can see the original COS line with the COS line number and everything. So you've got something to work with and to finish the conversion, because it can't handle everything. It can't parse inside a seg loader command field, for example. It can't parse into the target capabilities because the parsing of the command line is different. Little things like that. So COS help was just designed to be type in COS help, the name of the command, and whatever options you want to specify, and it'll pop back the converted line with a silent ignore on anything that doesn't mean anything or shouldn't. You don't want the user to map or carry across into his new environment. But access with a DT equals tape, and you'll be able to get online tape commands and stuff like that. And I'll explain these templates coming up here. So the only difference between these 4 different shell scripts were the templates, and I'm going to talk about the 4th one in a minute. But Pass 1 and Pass 2 was the full-blown version. that was started with the converter, that originally came to the converter and was upgraded to include update and various assigns and things that were in 3.0. It was at a 3.0 level. I stripped them down to NQS1, NQS2, and a help 1 and a help 2. And then I said, well, let's go one step further. If I take the output that's coming from this converter and put back daggers on it, I can execute the output. This was about 5 keystrokes. I did around the whole thing, my whole script that I had. I put back daggers and then an eval. So I had 1, 2, 3, 4, 5, 6 more keystrokes, and it converted the output. Now I can type in, and I call this thing COS. And there's just no extra effort in this, and I agree could be a dangerous thing on site, but a person can go COS space audit, and it'll do an LS for you. You know, it's for those people that are lazy or something or can't remember a command. But that was just a side thing, and I don't really expect a site to really want to do that sort of thing. But a user may want to do something like that too. So it's just a language translator going from a COS command line structure and parsing that and then converting it into UNICOS scripts controlled by these templates. So COS help is the one that I think I endorse, and then COS NQS would be useful in saving some time. But I think just putting COS help on the machine endorses hand coding it with a line-by-line translator in front of you to help you map the options, so to speak. And the options would follow the way the cross-references in this workbook go in terms of what they do to them. So your next page then has a template example. And I want to show you how this translator works. There are 2 passes to this converter, and the first pass templates look for things. They look for ownership fields on save, on access cards. You don't have them on save. It looks for assign statements, things like that, and sets flags. It looks for job rolling or rerun, no rerun, and things like that. It looks for things that it needs pre-knowledge of in the second pass. It also needs pre-knowledge of job accounting, charges, and perfmon, that sort of thing. SPI it will need pre-knowledge of, though that's not handled by the converter yet. So then on the second pass is a template for each JCL verb, and this is the one for update. And it begins template space update. And you can copy one of these templates and feel free to make a change or take a look at them. Inside the template we have the curly braces to delimit the whole thing on the top and bottom of the page. And then here's what it does. It has a variety of flags that you can set, whether they're uppercase or lowercase. And on the CJCL example on the previous page, we did have some flags that were set. And you can set up your own flags, but -F and then whatever flags you want. So you have the capability of adding flags. One of the flags I've added is a flag to convert all file names to lowercase, if you wanted that. So the first flag it tests is the C flag, and this is the comment flag. What this is going to do is echo the COS line as a comment. So the C flag is going to be able to switch on and off whether you want the original line echoed to your output. So they can see what they started from. And it's echoed as a comment with the # in front of it. That's all that line does. The second line, if flag E. E is for error handling, reprieve processing, exit handling. And I showed you yesterday how the converter handles reprieve processing with that do-done loop. He sets up a loop and breaks out of it for reprieve processing. On the first pass, this converter looks for the exit statement. If it's there, he will set this reprieve processing flag and create an exit handling situation with the NQS job that's coming out of it. So we're going to use this flag to put in the stuff to do that error handling. And in this case, what he's putting in there is the COS line number. He's setting up a variable that's going to, when the shell script you generate aborts, tell you what COS line number you were on when you failed. So basically it's breaking the script into steps related to the COS line number. So that's a debugging feature. Then we have the def proto statement. And at this point, the converter is going to parse the command line. He's found the verb update, and now he's going to figure out, these are all the things that I'm going to look for. Those are all the options, all the keywords that are on the job control statement. And we have P equals, I equals, all the things in update. Plus we have the option flags like ID, CD, these sorts of things. So he's going to look for each one of those things on the statement. And he's going to use them later. I kind of, in my mind, say at this point, the value associated with those fields is going to be that field, because we're going to substitute the contents of that field into the job later. So whatever P equals, if it's job PL, will be plugged in as job PL down here by single quotes down later in the job. So at the time he's defining those prototypes, he's also figuring out what keyword or what option, what parameter I mean, is being associated with that keyword.
Do you allow for defaults like under COS?
Yeah, there's a fill proto is the defaults coming up here.
Okay.
So you can set up what the defaults are, and I allow for them right now.
Okay.
But at that point, he's just saying, these are what all these things are going to be. And then if anything's not specified and it has a default, then it'll pop up as specified on this line fill proto down here.
Carry that default through to the UNICOS site?
It's being carried through by pass 1 and pass 2, but not the other ones. I'm dropping the $ right now. It's the way I'm handling it in the NQS job, in the NQS1 and NQS2 versions, to try to not map that COS idiosyncrasy to UNICOS, because you're going to need that backslash in front of that, and that just makes a bigger mess. So that's one of those types of changes that I put into NQS, is take out all the $ in the prototype filling defaults. So the original template converter, the pass 1 and pass 2 templates, the outputs of those ran on basic test cases, and that was the intent of it, was to try to map it and run it as much as possible. But the amount of output that it generates has always been complained about, so I've done everything I can to compact it and cram it, into less space. So the next thing he does then is puts into this output. We're just going to call it standard out. He's going to put into standard out. It's really a temporary file until he outputs it. But he's going to put into this output file the command update. And that's how it's spelled. In the newer releases, we're going to have 5.0 has both update and N update, the new update version. Then I fill proto. Now I could have done the fill proto before, probably. It's just happened that this is the way the original, that's the way it came out. In this case, P equals is going to become $PL. In the NQS1 and in the lesser ones, it would become just PL. And in update, we're going to talk about also if there's zeros. We have to look for 0 equals. Handle that differently, because that turns it off. And in UNICOS, you don't put a 0 there. You don't specify the option. For example, PL creation. You simply don't specify an input PL, and then it assumes you're creating one. $in is also specified. That's where your mods come in. And then $CPL is what comes out. And I've gone to just in and CPL on the NQS versions. Then I have just some cleanup. These are a bunch of variables, and I want to remove the string in case this was a second update statement or something like that. It's just a cleanup of variables that I'm going to use. I think the document calls them just strings, and there are also literal strings, which are the substitutions that occurred up here with def proto. So I do some cleanup. Then I've got a bunch of things I have to test for, and the only way I can do it is with this f string equal test. And I'm testing to see if the string is equal to a 0, a character 0. So I set literal string 0 to the character 0, and I set each of these strings I to whatever I equals is. And a lot of these techniques were simply copied from the programmer who developed this tool in his original templates. So I learned something in something he did and and converted it to the newer add-ins. So sometimes habits just show up in lack of single quotes, for example, around here to mean substitution of. Then I say if the string 0 is equal to p, in other words, if p is a 0, that means we don't have it. And that means we want to turn it off. And in UNICOS, that means do nothing. So he's saying if the string is 0, just don't do anything. Don't put a -p on the command line. Otherwise, he's going to do the else. And if we have the key p equals, then we're going to put into our output, double quotes is just the delimiter for this whole thing. A % means substitution to this template converter. So we're going to substitute a space, put in a space there, -p, and then another substitution, single quotes around p equals means whatever was after p equals until the next comma. So we're going to get a -p job PL in there. And he does the same thing for I equals, N equals, C equals. He tests if they're turned off, doesn't do anything. Otherwise, he puts a -I, -N, -C, and -S, and these all map. It's the same. The only thing that's not supported is a no rewind option on update. And with the new update, there's a lot of enhancements, performance improvements, longer deck names, things like that. So that dealt with my basic options, or keywords on COS, and converted them to options, translating the file name. Then I convert Q equals. In COS, a colon is what's used to delimit deck names on the Q option. And I'm going to go through that. Whatever Q equals followed it to the next comma, I'm going to go through it and substitute a space. The two double quotes are space delimiters, so there's a space in there. So he's going to substitute a space for every colon in there, and that converts it to UNICOS format. Now, in one of my simpler or my NQS templates, I also have a -L flag that I've put into here now, and it says, if you got the -L flag, convert all the characters to lowercase. So all these names with an L flag can convert them to lowercase as well, rather than keeping them uppercase the way they would be in COS. So this is an older template of what's officially on the tape, not what I've played around with these new versions. So then I can put my Q equals. It's a -Q. And then all the deck names are spaced by spaces. CL equals is just a translation, except it's a -U option. Def equals is a -D. So now I've handled all the basic keywords that are associated with update, and also handled any defaults that were up here. The next portion with this version of the converter, in UNICOS, all these options, CD and ED is often used, and ID is often used. I don't know that they're coming. And in UNICOS, you have to have a -O option there to specify these. Now with this converter, it only catches update on the second pass, and it doesn't have pre-knowledge that any one of these keywords could come in any sort of order when he's parsing this thing. So I just forced it to say -OID. That way I knew that if any of these other options were specified, I could put them in there, and the -O option would be in front of it. Otherwise, I'd have a big mess. Now on the newer version, and it hasn't been done yet, but on the first pass I can look for any of these keywords and set a flag, and then on the second pass say, if we have this flag, put -O, that sort of thing. And then all the keywords that are specified. So that was a quick fix for me to make sure that we had a -O there and that these could come in any order that I wanted. And ID I forced, basically, which gave you deck list ID. So if we have the key, put in there a CD, all these are lowercase rather than uppercase. And the only one not supported is an NR, no rewind. And that's silently ignored as far as update conversion goes. So now we've converted everything that's on the command line, everything that's in this def proto up here. The rest of this then is to handle listings. The way we handle listings in UNICOS is IO redirection at the end of the command line. We don't use -Ls and, or E equals and L equals, those types of concepts. So in this case, we then test to see if L is 0. That means listings will be shut off. And listings are shut off by default in UNICOS, so we're not going to do anything. Else, if we have the key L equals, that means we had some sort of listing data set that we're going to dispose or something later. And here we're going to put a space and a single greater than sign saying redirect into whatever L equals was. So you're going to get a file created with that listing name. And the same thing with the error listing. The first one is standard out. The second one is standard error. And standard error is a 2 in front of it. A 2 is going to redirect standard error to whatever file E equals was equated to. Then I deal with reprieve processing. I said if the flag E is set, then I'm going to put a double bar break at the end of this command line. And that means if something goes wrong and updated, aborts abnormally, I'm going to break out of the loop and execute whatever was after the exit statement in close. So that's my exit handling. And I have a new line there. Else I put a new line, meaning I'm closing my line off. And then I do some cleanup. I remove these strings again. So that's the update template. And you can go in and take a look at these templates. Pass 1 is just setting flags for first pass, what the flags are for. We're going to talk about the file system mapping that occurs here, but he's got 2 variables, one for his temporary file system and one for his permanent file system. And job temp would be whatever temp dir is, $temp dir. And then COS PFS would be probably $home. That's what it would translate to. And then ID would be the directory under $home. We also have a bunch of registers set up for G0 through G7, J0 through J7, and a couple other variables that we can create in the UNICOS environment if our job used them. Again, ampersand data blocks are handled in here. A lot of this stuff was inherited from the previous developer, really, and he had all this stuff in there. The assign command down here, we say if we have the keyword DN, that means we're using an assign with a DN option, and we're going to set a string assign to whatever DN was. That'll give us the Fortran unit number later, and then on the second pass we're going to use that. And we also have a charges flag that we set. We're going to set a literal string CH to a 1, and then on the second pass, if CH is a 1, then we know we have job accounting required in the job, and the charges is specified somewhere in the job. And then it goes on with a variety of other ones. So those are all the things for first pass. And then the second pass starts off. It has a preamble and a postamble template, and this is just the preamble. Stuff that goes in front of the job and at the end of the job. And in here, for example, we can put in the template version. Now, prior to UNICOS 4.0, these templates are old, but prior to UNICOS 4.0, job and account cards were accepted by USCP when the stuff came in from a station. So you may have seen UNICOS job examples before with job and account cards in front of them. With 4.0, that support went away. That was something that MVS stations used and needed. So this stuff still shows that, and it actually converts the job and account cards into request name and stuff like that. So it has 2 flags in here then. It says if we're a batch job, in other words, the B flag is set, that means we want to create a batch job, and we want job and account selected, then we're going to use a job and account card instead of UNICOS techniques, which is going to say if string job, then we're going to put into our output whatever that job card was. And if string account, we're going to put in the output whatever the account card was. And it just copies them, basically.
So does the user call this pass 1 himself?
Well, this is pass 2 here, but the shell script itself is what hooks up the appropriate templates.
Okay.
And the user could copy them and create his own little script. Right. But the way it's set up, if you look at COS help, CAD it, you'll see that it specifies the particular templates that I want them to get. Pass 1 and pass 2 are the defaults, and that's what we're looking at. The NQS and all the other ones are the shorter versions. So the only difference between all those 4 scripts is the templates they use, specified in the script. If a user wanted to, though, he could copy the templates and add his own stuff or do his own things, tune it to whatever he wants, but it's probably not worth his effort. I would recommend each site have one person that uses this as a toy to help get his users trained easily, because he can throw in text and give them all kinds of little messages or problems that have been found in a particular command and have all sorts of output come out, generate a report on the conversion. Trigger it by a keyword. Somebody used this keyword somewhere and learned about it the hard way. You put those comments in somewhere. So the next flag then says that the J is a capital. That says we're not going to have job accounting selected. So if the J flag is uppercase, and that was done typically on the CJCL line like we invoked a couple pages ago, then uppercase says we're going to use the UNICOS accounting method, and we do a USCP validation card, which is user equals PW equals. And we substitute in there whatever the UPW or APW was, and also the account number. Now these will probably more than likely be changed. And the converter will also not deal with account numbers. In UNICOS, the way you deal with an account card, if its purpose is to change the default accounting of the job, if a person runs under several different accounts, in UNICOS there's a new account command. So at the beginning of an NQS job, you'd put new account and then whatever the new account number is he's charging it to. In UDB Jan, set up those account numbers for his user entry. It says which numbers he can charge it to. And if not, it reverts back to the original charge number. So an account card's purpose may be, and this is what the JCL converter isn't smart enough to figure out, may be to change the accounting from something that they normally run under, so that they can run under several different charging account numbers. And the converter can't deal with that. So you would want to go in there and do a new account or something like that. These outputs, you have to really go in and understand what you're trying to get out of the thing when you're done. Converter's not smart enough for it.
How does the converter know what your default account number is?
It doesn't. That's what I mean. You're going to have to go in and change that. And if its purpose is to change the account numbers, you're going to have to add a new account command as well. If its purpose is to change from a default account that you normally run under. So the converter can't handle that stuff. It has no understanding or meaning and can't map it to UNICOS. It's just a given that the programmer is going to go in and clean up what comes out of this thing. It also it depends upon whether it has APW or UPW up here. Determines which field he uses to plug in there. The next one then says if it's a batch job, and typically you're going to map these to batch jobs, he puts in a bunch of NQS directives. We've got a whole stream of NQS directives. All the fields on the job card relate to NQS directives, and they're documented with a QSub command. So just one by one, chalk them off. Now this is still 3.0, but with 5.0, several more, like tape equals, SSD equals, things like that can also be mapped straight over. Though the size of the SSD may not be a valid number anymore, but at least it gives them something to start with. You can go in and clean up and tune from there. So we specify that we're going to run the Bourne shell. This is just a safety check, so to speak, to make sure everything runs as Bourne shell. The converter maps everything to Bourne shell because Bourne shell is what most directly maps. Ifs are ifs, not some construct that C uses. Request name. The job name is converted to the request name. Just translates the name. Combine standard error and standard out. I think in the future I would remove that from the converter. because it makes it harder to debug finding standard error buried in the middle of standard out, because they will be intermixed. And to find the operand range error message in the middle of your data is rather disturbing to me. I like to see it where the numbers were failing too. So that's something we've always put that in there because of habit and demonstrating. In COS they come back as one data set, while in UNICOS we'll make them come back as one data set. But that leads into debugging problems and finding standard error information. We'll also convert the MFL field to a -L capital M, the time limit field to a -L capital T, and also on the first pass I had a string called NRUN, says no rerun. If the job had a no rerun in it, then I'm going to set a no rerun flag. A -NR tells the NQS daemon, don't checkpoint this thing, don't take the time to checkpoint it. And do a %\n says a new line again. So that was just a null field. So now I've translated the job card, and the account card you can't really do anything with. You're going to have to go in and hand code that. It also has the option down here putting in version information, so you get the date to the converter, date to the templates, that sort of stuff. If you want that stuff, I generally throw that out. I just want to look at the output. And then it removes a bunch of strings and goes on with the other stuff, like puts in job accounting, things like that. So that's just to show you a little bit what the templates look like, so that you see how they start and look when you open them. And you can print them, page them, take a look at what's in them.
CJCL then reading all these templates is a C program or something?
Yes, all four of these are C programs, and in fact they're designed to run in IBM as well. They're designed to go into any C environment, and the makefile even has tests to see if it's a Sun or an IBM PC or a Cray, things like that. Though I don't know that anybody supports the other environments, that it's built that way. And they're all written in C. The languages of the templates is documented in your anthology. There's a 7007 manual that was put up on an earlier page that documents the language of this converter. So a site can really do a lot with these templates and put an interactive help tool in there and wrap it, tune it to the way they want to do it, package it the way they want their users to see it. Phone numbers to call if you hit this particular option even. You know, stuff like that could be done. The converter has lots of limits though. It's not an intelligent converter, it's just a one-to-one translator. Takes it and converts it. It cannot handle multi-file data sets, multi-file $in. It doesn't know what to do with copy, skips, rewinds. It'll do a copy D and copy F, can't do a copy R. And it treats a copy F the same thing as a copy D, that sort of thing. $in is converted to one here document. So you get this here document named $in the full-blown templates, or just in the shorter templates. So that type of stuff you should probably reevaluate anyways in terms of implementation. And CDBX is the key decision to split them apart into subroutines in a directory, at least until you debug it and implement it. Then you could probably collapse it into a PL or something like that. So file position across job steps, copy, skips, rewinds, you can't do anything about. Typically those are on $in, and you just simply have to go into $in and reapproach it, redesign how you're going to do $in. Possibly pull it out. There are some limitations on if statements and set statements in terms of operators and operands. It also can't find procedure definitions within ampersand data blocks. And 01 Systems was a site using that technique, where they had procedures defined within jobs that were specified as ampersand data blocks. So it can't catch those. It just isn't smart enough. It just treats an ampersand data block as a block of data, converts it to a here document. Parsing a text field. It can't deal with the AP fields to find out on a fetch and dispose whether it's tape or disk, some of those things, and what the volume mount name should be. So you have to go in and fix up those commands. It will convert what it can, but it's not clean enough to just run it. You're going to go in and change some fields. So its purpose is to save you a lot of typing and keystrokes, and also to give you help to map one-to-one what options and things you have. It can't parse the target option in COS. It doesn't follow standard COS command line parsing syntax formats. It doesn't follow the standard. The target command in UNICOS is an environment variable. And it can translate up to the first couple of characters. As soon as it hits the colons, it loses count. In COS, target goes something like CPU equals XMP, and then it switches to colons and stuff like that. So because of that, it simply can't follow it. It doesn't have a parser built for that type of syntax, which is also the same problem within segloader, within the command field. It can't go in there and parse it correctly. I have had to go in there and catch keywords in there, but it loses after a certain equal sign depending upon what's in there. So it's not consistent enough. But you're going to have to go in there anyways, and lib equals is going to be a path name that has no meaning on COS to what it is on UNICOS. So your path names for libraries and stuff will be different. But I think this converter can save you a lot of work. This is
Can our side analyst get a copy of this?
sure. Yeah, I 01 has a copy of it supposedly. They've written 2 tapes here and taken them back at 2 different times. So either the tape was bad again or it's floating around the system somewhere.
Sean has it.
Yeah, Sean would be the one.
She's the one who couldn't read the tape the first time.
First time, yeah. Now the converter doesn't map the file system the way 5.0 is set up now. The converter would have to be changed. It's not done right now within the converter to convert an NQS job into $tempter usage. There's nobody to do the work right now. So the old way that it did it was to put everything under $home. The problem with that is if an application uses a lot of file system space, you're going to have to need that space to that one particular file system group, and somebody else is going to want that same space. The advantage with the tempter variable is that it puts it where the administrator wants it, so that these applications that use a lot of scratch space don't cause a lot of overhead for a particular user's file system that could be used elsewhere in the system. So before we were running under $home all our NQS jobs, but then everybody needed a huge file system to run their applications. So we said, well, let's put the file systems together for NQS jobs. And some sites will have as many as 4 disk drives just for the NQS jobs to run on. Call it /work, or around here it's under /temp, for example. By the way, I looked at during lunch, and the 218 does not have the tempter variable up to date set properly. The other machines will create a directory for you. So the way while I'm on this, the way we did this here will not work on 218 right now, but that's the way you do it in official 5.0. It's just the release phase that the serial 218's in. If you echo $tempter, it'll just give you /temp, and it should give you /temp/.jtemp with a number, and that's the way a 5.0 system is supposed to look. So this is kind of a mess here, but the converter mapped everything under $home with a structure called COS PFS, and then it would expect under it ownership, ID, PDN, and if additions were specified, one more level of addition. And I would throw most of that away. I would convert and save just ID and save just PDN and use that under $home. So $home acts as the ownership, and the user would then be expected to put all of his permanent data sets with the ID and the PDN that they have in COS. And that's the only attribute that they'd carry. And they throw away any older additions that they don't want, that sort of thing. So the converter is designed to actually pull out all of this stuff And in my smaller templates, the only ones I want to keep are ID and the PDN. DN is going to be used, but it's going to be used for this name in the temporary directory up here. So the picture you have in your workbook is more like what the converter as released is set up. And what I've messed up on my slide is the stuff that's being taken out for the converter versions that I have. And you still have the other version, it's just the full-blown version, what's called COS job. So right now, the way it's set up, under $home, I'd have a directory with the attribute from the ID field, and then the PDNs that were in there. Then, under /temp, which is where the 218 file system puts tempter, I would have this, my $tempter is the path name to get to my temporary directory, and it's unique. The system will take care of it for you and unique for each job run. And under tempter would be all my DNs, all my files. So my job comes into the system, it executes this in the .profile and changes to my temporary directory. Now in 218 you'd then have to make your own job directory and change into that one or something like that. But in fact, the example in the workbook is what would work on 218 right now. This would only work on 1101, for example. So when my job comes into the system, .profile puts me into my temporary directory, and I take it out of the JCL converter. Right now, it's all explicitly in the JCL converter with these templates. So I bury it into .profile. Then when I come into the system, anytime I do an access, that means I'm getting a data set from somewhere. A fetch comes from a front end, and those will get translated. So the accesses become copies, and I'm going to copy my PDN ID. I'm going to get this path name here and copy that into my tempter directory as DN. And then as my job's running, he's going to be working with DNs. And all his DNs will be his local data set names. And that's what a local data set concept is in UNICOS. Is the data sets that are running in this tempter directory, and when the job terminates, they're going to get all cleaned up by the system. They go away, just like in COS. So an access is to move that thing in. Now the converter isn't smart enough to figure out, well, we could put IO redirection and just if it's reading in it on Fortran Unit 5, specify the full path name and use a less than sign and read it into the application. So you could go in and be a lot smarter than this converter could be in concepts of access and stuff like that, and save the overhead of that copy. Then when the converters or the job would be running, he'd be creating all his files in here as DN, and anytime he wants to save something, a save would be to move the thing out of that directory. You could use a copy or a move. They actually amount to the same thing if they're across file systems. If it's in the same file system, a move simply renames the inode. But if it's across file systems, he has to physically move it from one physical area of the disk drives to another physical area. And typically, this is a different file system. So it would result in a copy back. But if it's coming out in standard out, you could try IO redirection on the output of the application and do the writing into the proper file system. And the converter's not smart enough to figure this stuff out. It just does a one-to-one translation of what it sees in JCL. So that's what a save and access are treated as. Also procedures. It specifies a variable for proclib, and all the procedures are supposed to be files in that directory proclib. So I myself would prefer to use it just as an interactive, line by line, help me translate this line type of thing, than try to let it be too smart. Got a job example here on top of page 913, and this is where I show what you can do in UNICOS that you can't do in COS real easily. Originally, when I was using this converter, I wanted to be able to run the converter in a batch environment because I thought many a site would be stuck with access to the converter just batch. So I wrote a batch job to run this thing, and that's what we've got here. But I'm using the UNICOS version. I'm not using the COS version. And this is what the job looked like. I've got my USCP validation card that they would require, the request name, combined standard error and out, set my -X flag. That's so that I can debug this thing and see what happened. And then I create a shell script, lines 6 to 18. This is just like in COS you'd create a procedure with proc in a job and save $proc. That's what I'm doing here in UNICOS, is creating a shell script. So the advantage of this is that at the end of my job I can invoke this shell script called CVT with a variety of different invocations, and I don't have to specify all these lines over and over again. So inside the shell script then, I'm going to invoke this on line 21 in this example, but inside the shell script I set a -X, I make a directory for procedures on line 8. Line 9 I fetch my source in, and my source is going to be named whatever $1 was on the front end. I then run it through CJProc and CJCL and create an output, dispose that output off to the front end, but now I don't know what procedures I've found. So I have to figure out, well, this is the body of the job, what about procedures? I have to go in and find those. So on line 12 I changed to the directory proclib, which is where all the procedures got converted into shell scripts. And a parser is being put in front of each one of them. That may be the only reason you'd want to look at this kind of thing, is for saving the typing on the parsers. So I change in that directory, and then I invoke the remote shell to my front end. And this is something that I had to do because it's a Unix machine, but I had to make a directory off on the front end to put all these things in. I wanted all the shell scripts to come off the machine and go off to the front end. And then this is the only reason I wanted to show you this job, because I don't use this job anymore. I use the tool Interactive. But do a file for file in backdaggers around an LS. It's going to substitute each line that's coming out of LS for the variable file, and then dispose that file off to the front end. So it's like doing an audit, and everything that comes out of the audit is being disposed off to the front end. And that's something real difficult to do in COS, not a concept COS is familiar with. So that was something that the first time I did that was, like, wow, this is another place UNICOS is better than COS. Things you can do very easily. So I do a do-done loop for every file that's in the LS and dispose it off. 19, then I change the mode of this file so that I can execute it. All shell scripts simply need an execute permission to invoke them. And then I invoke the thing. So the thing runs. The source that I put in is on the bottom, 913. Not much, 19 lines. I've never counted the lines on the facing page, but that's what came out. And again, this is the released templates, not anything that I've been experimenting with. So I got my job card converted. If you look at it, TNG was passed as user and password. I get my born shell selection. The job name was CFT. Time limit was 100. That's passed. I get a set-XU. This is all coming out of the preamble stuff. And in the future, that should probably be a VE, would be a better way, the way we're doing it nowadays. A V for verbose mode rather than X mode. E saying that you're going to abort on an error status coming out of a code. U, I guess, could be specified. U says abort if it's a null variable. If you encounter a null variable, shell variable, abort. So that was a catch-all. Then I set up my path names. I'm saying COS PFS is under $home, proclib is under $home, and job temp is under $home. This is the way the converter's released in distribution, and not fixed up for 5.0 yet. So that gives the opportunity to the programmer to go into one place and make changes of where he is in the file system. Then I make my directory, job tempter, and I change to that directory. And right now, job temp is under $home. In fact, something I should point out, under job temp there are $2 signs at the end of it. That says parent process ID number. Substitute that in there. So I get a unique directory number associated with the process number. So I'm going to make that directory, and it's a unique name under $home. And I change to that directory. I do a CD. So in the newer converters, all three of the previous lines in the makedir would go away, and the only thing you'd have is the CD, unless you wanted to bury that into the user's profiles, or the system profile even. Okay, then we have our exit handling. You'll note that the facing page did have an exit statement in it. So on the first pass, you set a flag saying on the second pass, do reprieve processing. It's turned off by default. And we do a while test 0 equals 0, do, and then at 3/4 or so, the bottom of the page is an exit and a done. That marks the exit location in the COS job. And everything past that's going to be done if we break out of here. So that's put in. Then we go on to our here documents. Note that it says ampersand data comma $in. That's what CJ Proc converted it to. We get the COS line number. That was echoed out, so I know I'm 11th line in my COS job. Then the here document, and it's going to cat it into a file, in this case called $in, and there's a backslash in front of all the dollars. That's the way the converter's released. My here document in data, then my job statement, it's already been processed, so there's nothing after it. Account statement, it's been processed, so there's nothing after it. The access statement. In these days when we ran it under $home, all we had to do was a link. We would link our COS PFS project data to our job temp file name. Now with the new job temp, or I'm sorry, with the new tempter variable, we would do this differently. So a link would be converted to a copy. Then we have the assign command. And the assign is done on a job step level, like I showed you yesterday. env, file env equals ex1, and then the assign command, and translating everything found there. Now, again, the converter isn't smart enough to pick Fortran Unit 5 and 6. And those are already pre-connected, do not have to be assigned. Converter doesn't know it, it's going to pop them out to the screen. But you would want to use IO redirection, less than and greater than signs on the invocation of the command. So that's a snag. This thing doesn't have any artificial intelligence, so no AI in it. The next line is the CFT statement. Now, this is another thing the converter has to work around. The CFT in all the languages require the suffix at the end of it. So the way he does that is with a link, which means you create a second inode with the new name, and then remove that link when you're done. So he links $in to $in.f, and then the compile statement comes out. Compiling, he's going to create $BLD as an output, $BLD.o, and then read in $in.f. And again, the scaled down templates can have a lot of, like the dollar signs are taken out and a lot of the extra stuff worked out of it. But there's no way of immediately dealing with the .f, because you have no way of, when you name the source, knowing whether it's Fortran or C or whatever it is. I guess you could assume it's all Fortran, go from there. Then we have our segloader statement. With segloader, again, I had to have a directives file, and this can change with 5.0 now because segloader can specify directives the same way as COS. Before, you had to have a directives file. Now you can specify it on the command line. So in these days, the converter created a directives file with map equals none just as a starting point to guarantee that one's there and there's nothing in it. It won't do anything. So that was a way around a hole. And then if any other directives were found, it could put those in that directives file as well. The seg loader statement then had to have dir at the end of the command line. It would read that as the directives file. Now, since we had a assign specified, we get an assign statement of env file env equals ex1 needs to be specified when we invoke the thing, so that the IO libraries at that executing step know to reference ex1 for the IO attributes of the files. Now, in this case, it was for Fortran Unit 5, and we didn't need it. That was a flaw in the converter because it can't figure out 5 and 6 being unique. But in fact, it should be get rid of this assign up here, and then down here on the invocation, get rid of that, and simply redirect our, it's called file. So a programmer would have to go in and clean this up. And everybody in COS does an assign to 5 and 6, and the converter can't handle that. Then we have a release, and the release is a remove. It removes the file in our temporary directory. Now, when we do a remove in COS, or a release in COS, it also releases the Fortran attributes that are associated with an assign. So we have to also remove this file from our file env, and we do a test to see if we've got a file environment variable, and if we do a delete of that file, any line that contains the characters file in it, and move the fixed one, the edited one, on top of the original one. So that removes the line that has the dn equals file. Line 8 then, an exit statement. When a job's normally running, when he gets this far, he reads an exit as terminate the job. So the way we terminate this job then is change back to the home directory and remove our temporary directory, and then exit the shell script. So that's our cleanup for a normal termination of the shell script. Now note that there was a comment, I kind of wiped it out, but double bar breaks on seg loader, on the $ABD. Again, if it aborted, it would pick up on the right side of those double bars and do a break out of the loop and pick up processing right after the done, right down on this line. And the first thing it's going to do is echo to your output, exit processing entered at COS line number, COS LN, whatever that was. So that tells you where you were in the job when it kicked out, a debugging tool. After the exit statement was the debug statement, and that translates to debug, just straightforward. Now the converter isn't smart enough to know that we're past the exit statement now, and it still puts a double bar break on the end of it, because it doesn't know whether it's inside or outside of that do done loop. So that double bar break wouldn't really do anything. Then it echoes to the output, this is the end of the job, changes to the home directory, removes the temporary directory, and exits out of the shell script. So that's the output generated by what's hanging in distribution, the 2.0 release. And there's a variety of other jobs showing it running on COS, what it would look like on COS and stuff. There isn't anything else really in this chapter worth going through. That, by the way, that output we just looked at was not the full-blown output. The full-blown output is on pages 21 and 22. And that throws in the environment variables, throws in the version dates, a lot of extra stuff, some comments and things like that. And imagine putting in 13 lines of code and getting all of that and understanding, you know, why it would bother somebody. So that's why I think COS, the best way to treat migration, in my opinion, is to use COS help, make them go through it by hand, but restructure it as they're going through it, and use something like COS NQS or COS help to save them time and cross-referencing things and that sort of thing. And then they can do it a lot more carefully. So if there aren't any questions, take a look at that section, play around with the tool, copy the tool and the templates and stuff, and try modifying the templates. Try making your own change to the templates. Those that are interested in that, that's what we'll be able to do in the next couple days. I think any site should learn how to tune them to the way they want their site to use that tool. I also only recommend running it on UNICOS. It's really not worthwhile running it on COS. It's not going to save you any prep time. The only thing you can really do on COS is look for the library problems, the library applications. Come up to Mendota Heights and convert them in our AppCon class or machine time that you can schedule up here. You're better off treating it that way than trying to convert JCL on the COS system and not be able to do anything with it, you know, except be confused and scared by it. So why don't we take a break?